Stationary points under nature, SQA Higher Maths, 2019, paper 1, question 1. Find the x-coordinates of the stationary points on the curve with equation y equals a half x to the 4 minus 2x cubed plus 6. Stationary points on the curve when the y by dx equals 0. So we can find the y by dx. 4 times a half, well that's 2x cubed, take away 1 from the power. 3 times 2 is 6, so minus 6x squared, and then 6 goes to nothing. In our little statement, stationary points occur when the y by dx equals 0. We've got 2x cubed minus 6x squared equals 0. Common factor of 2x squared to get x minus 3. And that means that x equals 0 because 2x squared equals 0, or x equals 3. And there we are. Simple as that. Okay, the discriminant, SQA Higher Maths 2019, paper 1, question 2. The equation x squared plus k minus 5x plus 1 has equal roots. Determine the values, possible values of k. Well, if it's got equal roots, that means that we write for equal roots, that implies b squared minus 4ac equals 0. So our a is the number in front of x squared, our b is k minus 5, the number in front of x, and our c is just 1. So for b squared minus 4ac, we get k minus 5 squared minus 4 times 1 for a times 1 for c equals 0. Expanding k minus 5 all squared gives me k squared. Minus 5 times 2 is minus 10, so minus 10k. 5 5s is 25. And then we've got 4 times 1 is 4 equals 0. So that's k squared minus 10k, 25 minus 4 is 21 equals 0. And if we're lucky, that will factorise. So we've got k and k. 7 3s is 21 and 7 and 3 make 10. So it's definitely 7 and 3. Minus 7 minus 3 is minus 10. So k equals 3 or k equals 7. And we're done there. SQA Higher Maths, paper 1, question 3. Circle C1 has this equation and C2 has centre 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of circle C2. So we have got our equation up here, and just remember, from our equation, x squared plus y squared minus 2x minus 2y minus 26 equals 0. You're given at the start of the exam paper the radius. The radius is quoted as equaling the square root of g squared plus f squared minus c. And your g and your f, well, this is called 2g and 2f. So 2g is minus 6 and 2f is minus 2. So my g is minus 3 and my f is minus 1. So my radius is equal to minus 3 squared plus minus 1 squared. Take away c, but it's a minus already, so plus 26. So that means that going down here, my radius is equal to the square root of 9 plus 1 plus 26. That's the square root of 36, which is equal to 6. So we've got our radius, and we know the circle centre is 4 minus 2. So we know the equation of C2 must equal x minus 4 squared plus y plus 2 squared equals 36. And we're done there. SQA Higher Maths 2019, paper 1, question 4. A sequence is generated by un plus 1 is m, un plus c, where the first three terms are 6, 9, 11. Find the values of m and c. So we have got 6, 9, and 11. So we could call that the first term, the second term, and the third term. So the second term would equal m times the first term plus c. And the third term would equal m times the second term plus c. So we could just sub them in. So u2 is 9, is equal to 6m plus c. And u3 is 11, that equals 9m plus c. Simultaneous equations to solve. So we can just do 2 take away 1. That gives me an 11 take away 9 is 2 is equal to 3m. So m is 2/3. Sub that in, we get 9 is equal to 2/3 times 6 plus c. 6 2s are 12 divided by 3 is 4. So 9 is equal to 4 plus c, and therefore c is equal to 5. It then says part B, calculate the fourth term of the sequence. So for part B, u4 is equal to m, which is 2/3, times u3, plus c, which is 5. And u3, remember, the third term was 11. So that equals 2/3 of 11 plus 5. So 11 times 2 is 22 over 3. So I might as well make the 5 15 over 3. So we've got a common denominator. 22 plus 15 is 37 over 3. And if that's already simplified, I'll be done. Well, it is simplified, so I'm done. SQA Higher Maths 2019, Paper 1, Question 5 on vectors and collinearity. So it says show that the points A, B and C are collinear and then state the ratio that B divides A to C. So let's do part A first. To show that 3 points are collinear, especially 3D points, we can just compare A to B and the vector B to C. So let's do A to B first. Vectors A to B, remember, is B minus A. So vector B is 4 minus 1 and 0. Minus A, which is 1, 5, minus 3. So we've got 4 minus 1 on the top is 3. Minus 1 minus 5 is minus 6. And 0 minus minus 3 is 3. So we get 3 minus 6 and 3 for the first. The next one, B to C. That's C minus B. So that is 8 minus 9 and 4. Take away 4 minus 1 and 0. So 8 minus 4 is 4. Minus 9 minus minus 1. Well, that's plus 1, so that's minus 8. And then the last one, 4 minus 0 is 4. Now, to show that they are collinear, we need to show that these two vectors are parallel. How do we do that? Well, all you have to do is show that you can times 1 to get the other. So if we just compare each element in turn, we do that divided by that divided by that, and that divided by that, and make sure we get the same answer. So 4 divided by 3 is the first one. And then we've got minus 8 over minus 6. Well, if I simplify that, divide that by 2, you get 4 over 3. So that's the second element. And then the third element, 4 over 3 again. So we can then say quite easily that B to C is equal to 4/3 of A to C. A to B, sorry. And therefore, BC and AB are parallel. You could have also done the numbers the other way around and said 3/4 and said that A to B is 3/4 of B to C, and it would make no difference. But we've shown the parallel, and but B is a common point, which you can see because you've got BC and AB. So you just say B is a common point, and therefore AB and C are collinear. And we're done there. Okay, the chain rule, SQA Higher Maths 2019, Paper 1, Question 6. Given that y equals 1 over 1 minus 3x to the half, and x is not a third, find the y by dx. Let's get it ready to differentiate. So y equals 1 minus 3x to the minus 5. So the y by dx minus 5 in the front, 1 minus 3x, take away 1 from the power, so that's minus 6, and then times by whatever's in the bracket differentiated, which is minus 3. So tidying that up, we get minus 5 times minus 3 is 15, 1 minus 3x to the minus 6, and we're done there. QA Higher Maths 2019, Paper 1, Question 7. The line L makes a 30-degree angle with positive direction of x-axis. Find the equation of a line perpendicular passing through 0 minus 4. Gradient equals tan of 30, which is equal to root 3. 1 over root 3. So that means the gradient of our perpendicular is equal to minus root 3, since m1 times m2 equals minus 1. And then we can just use y minus b, y plus 4 then equals minus root 3 x minus 0. So y equals minus root 3x minus 4 And we're done there. Okay, integrating the find area. SQA Higher Maths 2019, Paper 1, Question 8. The graphs of y equals x squared plus 2x plus 3 and 2x squared plus x plus 1 are shown. They intersect at -1 and 2. Express the shaded area as an integral. So it's leading us through this one. Remember, to get our shaded area, it is the upper curve minus the lower curve. So just tracing this, there's my upper curve there, which is this one, and there's my lower curve there. So I do the integral between -1 and 2 of this minus this. So for part A, it's the integral between -1 and 2 of x squared plus 2x plus 3 minus 2x squared plus x plus 1 dx. Tidying that up, so -1 and 2. X squared minus 2x squared is minus x squared. 2x minus x is plus x. 3 minus 1 is 2 dx. So part A is done. Part B says calculate the shaded area, so work that out in other words. So for part B, our integral equals add 1 to the power, divide by the new power, plus x squared over 2 plus 2x, all between -1 and 2. Subbing in our numbers, we get -1/3 of 2 cubed plus 2 squared over 2 plus 2 times 2. That's our first one. Take away -1/3 times -1 cubed plus -1 squared over 2 plus 2 times -1. Okay, so then we need to work on this. So 2 2's is 4 times 2 is 8. So we get -8/3 for our first bracket. 2 2's is 4, divided by 2 is 2, and 2 2's is 4. So there's our first bracket. And our second bracket, -1 cubed is -1, times -1/3 is just 1/3. -1 squared is 1, so that's a half. And we've got -2. So we've got some fractions to deal with, and it was paper 1, so we're just going to have to keep going. -8/3 plus 6 minus, I'll just times them together to get 6. 2 and 3 is 5. So we get this. I will now just take the brackets away. -8/3 plus 6 minus 5/6 minus plus 2. Putting the numbers together, you get 8. And I've got -8/3 and -5/6 to deal with. That's 8. Doubling 8 is 16, so that's 16 over 6 minus 5 over 6. So that gives me 8. 16 minus 5 is -21 over 6. Changing that to a mixed number, 8, 6 3's is 18. And 3/6. Simplifying, 8 minus 3.5. 8 minus 3 is 5, minus another half is 4.5. Don't worry about all that extra substitution and what you need to do. You get most of the marks for getting to the point of substituting in, okay? So don't worry if you can't get that far. SQA Higher Maths 2019, Paper 1, Question 9 on vectors and scalar product. Vectors u and v have these components, where p is a member of the real numbers. Find an expression for u dot v for part 1. Well, u dot v is told to you at the start of the exam paper. If you forget, it's either got an angle in it, or it is times each element, then plus the second element, then plus the third element, all times together. So I can just write that down. I've got p times 2p plus 16, plus -2 times -3, plus 4 times 6. So then we can just simplify that, expand my bracket. I get 2p squared plus 16p plus 2 3's are 6, minus times a minus is a plus, 6 4's is 24. So that's 2p squared plus 16p plus 30 is our simplified u dot v. Part 2. Determine the values for p for which u and v are perpendicular.
Well, if u and v are perpendicular, that means that u dot v equals 0. And why is that? Well, if you look at start exam paper, you're given the formula sheet, which says that u dot v is also the size of a times the size of b times the cosine of theta. Now, if theta was 90, cosine 90 is equal to 0, so u dot v is 0 when they're perpendicular. But you could just memorise that. So u dot v equals 0 means I can write 2p squared plus 16p plus 30 equals 0. Take 2 out as a common factor, p squared plus 8p plus 15. So that's a quadratic. So from National 5 Maths, I'm looking for double brackets probably. Two numbers that times together to make 15, but add together to make 8. Well, that's 5 and 3. So it's plus 5 and plus 3. So that means that p plus 3 equals 0 or p plus 5 equals 0. Solving both of the equations, we get p equals minus 3 or p equals minus 5. And we're done there. Part B says, determine the value of p for which u and v are parallel. So if a parallel, that means that I can times this one by something to get this one. So let's just compare the elements. I've got minus 3 over minus 2, that's 3 halves. And similarly, I've got 6 over 4, which is also 3 halves. That means that if I times this one by 3 halves, I get this one. So I can just write that down. 3 halves of p equals 2p plus 16. So for part B, 3 halves of p equals 2p plus 16. So I've got that equation to solve. So if I put brackets around that side, that means I can times by the bottom. So 3p is equal to 2 times 2p plus 16. 3p equals 4p plus 32. So taking it over to the other side, you would get minus p equals 32 or p equals minus 32. And we're done there. SQA Higher Maths 2019, Paper 1, Question 10, Graphs of Related Functions. The diagram shows the graphs of f of x and kf of x plus a, with to find the values of a and k. So where's our f of x? It's this one here. And kf of x is the other one, plus a. So that's flipped upside down, and then it's maybe moved up or down. So to work out a, first of all, just compare it on this bit here. That's 0, 0. And that's 0, 3, it's clearly moved up by 3. Even if it's flipped upside down, it's still moved up by 3. So A is equal to 3. So we can just write down 3 straight away, no problem there. Now we need to find our K. Well, we know it's flipped upside down, so we know straight away it's negative. And how much? Well, just imagine if you flip this graph upside down, then you will be kind of drawing it like this. So this point here, 2 minus 1, will become 2, 1. So let me just take a note of that. That would kind of go up and become 2, 1 when it's upside down. But then we move up to 5. Now, even if I add 3, I don't get 5. So 2 times 1 is 2, plus 3 is 5. So that means k is minus 2. And we're done there.
Okay, integrating a trig function again with a chain rule. We've got Higher Maths 2019, Paper 1, Question 11. Evaluate the integral between 0 and pi over 9 of cos 3x minus pi over 6 dx. Exact value question as well because it's non-calculator. So let's start integrating. That becomes cos goes to sine, remember. We're looking at the start of the exam paper. The whole function, 3x minus pi over 6. But then we need to differentiate this. Well, that's just a number, so that's nothing. That becomes 3. So divide by 3. And that is the integral between 0 and pi over 9. So there's our first step. Now we need to just substitute in. So that gives us a third of sine, well, 3 times pi over 9, we'll just write, minus pi over 6. That's our first one. Take away our second one, subbing 0 in. So that's a third. Sine 3 times 0 minus pi over 6. Okay, so we can now, we'll just tidy that up, put an extra bracket on. We can now just evaluate that. So that gives me 1/3. If I take my first one, sine 3 pi over 9. So let's just do this. 3 pi over 9 is pi over 3. So I've got pi over 3. And then our pi over 6, we can think of that as minus pi over 6. Take away a third of sine. And then 3 nothings is nothing, so it's just minus pi over 6. So that gives me 1/3 of the sine of, well, pi over 3 is 2 pi over 6, minus pi over 6 is pi over 6. So we've just got pi over 6 now. Take away a third of the sine of minus pi over 6. So we're going to have to work out what the sine of pi over 6 is. So if you're thinking in degrees, pi over 6 is the same as 180 over 6, which is 30 degrees. So exact value triangles is how I always think of this. So if I got myself a triangle with 2 on this side, 1 on that side, then by Pythagoras, 2 2s is 4, minus 1 is 3, that is root 3. Now that was 60, so that one's 30. The sine of 30 degrees is equal to a half. You might have just memorised that yourself. If you think of a sine graph or a cast diagram, you can see that minus 30 would be about here. It's obviously minus a half for the sine of minus 30 degrees. 1/3 of the sine of 30, so 1/3 times a half, minus 1/3 times minus a half. So a third times a half is a sixth, a third times minus a half is minus a sixth, so plus another sixth because of minus times a minus, that is 2/6, that is 1/3. And we're done there. SQA Higher Maths 2019, Paper 1, Question 12. Two functions are defined as f and g. You have to determine f of g of x. So let's do this. Question A, f of g of x. Well, that equals f of, well, g of x is 5 minus x. So I'm substituting 5 minus x every time I see an x in f of x. So that is 1 over the square root of 5 minus x. And we're done there. Part B, state the range of values for which f of g of x is undefined. Well, it's undefined when either this is 0, because you can't divide by 0, or when 5 minus x is less than 0 because you can't square root a negative number to get a real value. So we can just write that undefined when, well, 5 minus x has to be less than or equal to 0, otherwise it's undefined. In other words, 5 minus x has to be bigger than 0. So we can then just solve that for x, taking x over to the other side, you get 5 is less than or equal to x, or to write that in a nicer way, x is greater than or equal to 5. And make sure you've written undefined when, okay? SQA Higher Maths 2019, Paper 1, Question 13, Angle and Double Angle Formula. ABC and ADE are both right angled. P and Q are shown in the diagram. You have to find cos P and cos Q. So for cos P, I'm going to need adjacent over hypotenuse, and for cos Q, I'm going to need adjacent over hypotenuse. So if I draw both these triangles out, I can work out the missing sides. So for the first triangle, where P is, I've got 1 in root 5. So I can do root 5 squared minus 1 squared, which is 5 minus 1, which is 4. Square root of 4 is 2, so I've got 2 on this side for the P. Similarly with the Q, I'll draw it as it looks. Q, we've got a big long side, and there's Q there, and it tells us the hypotenuse is root 10. It tells us the other side is 1, but then we don't need Pythagoras because we've got 1 right here, and then an extra 2 to make 3, because we've just worked it out, so this is 3. And now we can start answering the question. Cos P is equal to adjacent over hypotenuse, so 2 root 5. And part 2, cos Q is equal to adjacent over hypotenuse, so 3 over root 10. Part 2 says, hence determine the value of sine P plus Q. So for part B, we've got sine P plus Q. So that's an addition angle formula from the start of the exam paper. It is sine P cos Q plus cos P sine Q. And then we just substitute our values in. So we've not got a sine P and a sine Q. So we need to work out our sine P and sine Q. So let me just do that underneath. Our sine P is equal to opposite over hypotenuse. So 1 over root 5. Sine Q is equal to 1 over root 10. So now we can substitute our values in, being very careful we get them in the correct order. So we've got sine P first, 1 over root 5, cos Q, 3 over root 10, plus cos P, 2 over root 5, plus sine Q, which is 1 over root 10. Multiplying the top, we get 3, and then root 5 times root 10 is root 50, plus 2 over root 50. That gives me 5 over root 50, but all answers at higher maths need to be simplified. So I need to simplify that root 50 if I can, which you can, because it's root 2 times root 25. 25 times 2, which is giving you 5 over 5 times root 2. 5's cancelled to give you 1 left on the top and root 2 on the bottom. So it's 1 over root 2. And you're done there. Okay, evaluating numerical expressions, SQA Higher Maths 2019, paper 1, question 14. Part A, evaluate log 10 4 plus 2 log 10 5. So we've got log 10 4 plus log 10 5 squared, because I can take the 2 up. So that's log 10 4 plus log 10 25. And then we can combine that because we can times the numbers together. So it's log 10 4 times 25, which is log 10 100. Log 10 100 is equal to 2 because 10 squared equals 100. And there we are. Part B. Solve log 2 7x minus 2 minus log 2 3 equals 5. So we'll combine that into one log straight away by writing log 2 7x minus 2 all over 3, because a minus means we can divide. And that equals 5. So then using our rules of logs to eliminate, we've got a log on one side and a number. So 2 to the power of 5 equals this. So I can write that 2 to the power of 5 is 7x minus 2 over 3. So we need to work out 2 to the power of 5. Well, 2 2s is 4 times 2 is 8. Times 2 is 16, times 2 is 32. So we get 32. So 32 equals 7x minus 2 over 3. So we can times 32 by 3. 32 times 3 is 96. So 96 is 7x minus 2. Add 2 to both sides, so 98 is equal to 7x. Dividing through by 7 then, you get 14 equals x, or nicer, x equals 14. And we're done there. Trigonometric equations, SQA Higher Maths 2019, paper 1, question 15. Solve the equation sine 2x plus 6 cos x equals 0. And then solve a new equation for part B. So for part A, sine 2x plus 6 cos x, a sine and a cos, they're different from each other. So I will span the sine 2x to give me 2 sine x cos x. And this time we're working in degrees, plus 6 cos x equals 0. So although we've got a sine and a cos, there is a common factor, so I can factorise. So the common factor is cos x, but it's also got a number attached. 2 is also a common factor, so 2 cos x goes outside. That gives me sine x in the bracket here. And 2 cos x times 3 is 6 cos x, so plus 3 equals 0. And then we've just got 2 equations to solve. We can say 2 cos x equals 0, or we can say sine x plus 3 equals 0. This one gives me sine x is equal to minus 3, which has no solutions, because the maximum and minimum of sine x is 1 and minus 1. So this one, 2 cos x equals 0, means that cos x also must be 0. You should know that cos x is equal to 0 at 90 degrees. If you don't, there's a little graph for you just to prove it. 1 and minus 1, it goes along 90, then 180, then 270. So we can immediately say that x equals 90 degrees. You could also say it's 270 straight away, but if you didn't know it was 270, cast diagram would give you the other one because cos is positive. So 360 minus 90 would give you your 270 as well. And we're done there for part A. Part B says, hence solve sine 4x plus 6 cos 2x equals 0. Part B, sine 4x plus 6 cos 2x equals 0. So part A was sine 2x plus 6 cos x. So the numbers in front haven't changed, so it's not a multiple. However, the angles have just doubled, so the frequency's just doubled. So that means that our answers to part A was when x equals 90 and 270. So now it's just 2x equals 90 and 270. There's no real extra work to do. So for part B, I can just say straight away, 2x degrees equals 90 degrees and 270 degrees. But I want to solve it between 0 and 360. So there's going to be more solutions than that because I'm going to divide my answers by 2. So I just add 360 to everything. I'll just write that here, plus 360. Then it's going to give me 450 degrees. And it's also going to give me 630 degrees. And then I can just divide each of them by 2 to get 45 degrees, to get 135 degrees, to get 225 degrees. And the final one is 315 degrees. And we're done there.
Okay, unusual circle questions. SQA Higher Maths 2019 Paper 1 question 16 had this one. P is the point with coordinates 4k and C is the centre of the circle with this equation. Show the distance between P and C is given by square root of k squared plus 4k plus 13. So part A, we've got our points 4 and k and the centre of our circle is equal to, well, let's have a look. We've got 1 minus 2. So we can work out the distance between them. That is going to be the square root of the difference in the x's, 4 minus 1 squared, plus the difference in the y's, k minus 2 squared. Tidying that up, we get the square root of 3 squared plus k plus 2 squared. That equals the square root of 9 plus k squared plus 4k plus 4. Which equals the square root of k squared plus 4k plus 13 as required. Part B says, hence otherwise find the range of values of k such that p lies outside the circle. So let's draw a little picture for this. We've got a circle and the centre of that circle is 1 minus 2. And we can look to see what the radius is. We know the radius is 5, the square root of 25. So that distance is 5, that's our radius. So if P is outside the circle, then clearly the distance between the centre and P must be bigger than 5. It has to be over 5. So we can then just say that the square root of k squared plus 4k plus 13 is greater than 5. And we can go from there. That's because our radius, remember, is 5. So, quadratic inequality, square both sides, k squared plus 4k plus 13 is greater than 25. Taking the 25 over, we get k squared plus 4k minus 12 is greater than 0. And this is a quadratic inequality, so we examine the roots. So looking at our roots, we've got k squared plus 4k minus 12 is equal to 0. Double brackets, we get k and k, 6 and 2, plus 6 minus 2 is 4. So our roots have to make k equal to 2 or k equals minus 6. Drawing a quick sketch then of that graph, we get 2's over here somewhere, minus 6 over here. It's a positive k squared, so it is a happy face. We don't need the turning point or anything because we're just looking to see when is this bigger than 0. Well, it's bigger than 0 above the x-axis, so it's over this side, it's always bigger than 0, and over this side, it's always bigger than 0 as well. So our final answer is k is less than minus 6, or k is bigger than 2. And we're done there.
SQA Higher Maths 2019, Paper 1, Question 17. Express sin x minus cos x squared in this form, and then find the integral. So it's p plus q sin rx. I'm just going to assume we need to expand the bracket. I think you should too. So we've got sin x minus cos x times sin x minus cos x. That equals sin squared x. Sin x times minus cos x, and then minus cos x times minus sin x is minus 2 lots of sin x and cos x. And then minus times a minus is a plus, so plus cos squared x. But we know that sin squared plus cos squared equals 1. So we get 1 minus 2 sin x cos x. We're almost there. There's no cos in this at all. But look at the start of the exam paper. Sin 2x is 2 sin x cos x. So that is equal to 1 minus sin 2x. Have we got it in that form? Well, p is 1, q is just 1 or minus 1, and r is just 2. So yeah, we're done. Hence, find the integral of that. So that means for part B, we can do the integral of 1 minus sin 2x dx, and that's just the chain rule. Integrate 1, you get x, minus sin integrates to cos, so plus cos 2x, but then we need to times by the 2x differentiated, so times a half, because we divide by the differentiated, then plus c. So that is equal to just x plus a half of cos 2x plus c, and we're done there.